Hope you're doing great. Welcome to my YouTube coding channel, The Consistent Coder. So today we are going to solve the problem, the two sum. This is an easy problem on Leetcode. So let's get started. So given an array of integer nums and an integer target, so we have to find two numbers such that they add up to the target which was given, and we have to return the indices of the two numbers. So for example, here in the example one, we have 2, 7, 11, 15, and the target is 9. So basically we have to find two numbers in this particular array such that they sum up to the target, in this case 2 plus 7, and we have to return the indices of those numbers, not the numbers themselves, but the indices. And given that we can return the answer in any order, so we could return 1, 0 as well. And it is also mentioned that we have exactly one solution in the given array, and we may not use the same element twice. So for example, here in the example 6, we have the element 3, and at the index 0 we have 3. If we add the element twice, we could actually get the target, but that is not a valid solution because we cannot use the same number twice at a given index, right? We'll first solve the problem with the brute force solution, and then we'll go on to the optimal solution which was asked in the follow-up question. Okay, so here we are given an array, right? So the first example is 2 and then 7, 11, and then 15. So the target we have here is 9. Okay, what do we need to do? So let's think about it for a few minutes before actually getting into the exact solution, right? So we have to select two numbers, right? And we'll have to select two numbers basically from this array. What I'll do is first I'll select one number. I'll select this number and I'll fix it. And I am making the assumption that, this is one of my two numbers. If I say this is one of my two numbers, okay, of my final solution, then what should be the other number? The other number will be in one of these. Why? Because he mentioned that there is exactly one solution and the solution exists and the two numbers are different, right? Obviously. So if I say this is one of my number in the two numbers that are going to be the solution, the other number is obviously in this one. Make sense? Okay. Now what I need to do is I just need to sum this particular number 2 in this case with each and every other number in the rest of the array. So if I do that, I am bound to find my solution, or I might not, because my initial assumption may be wrong. What did I initially assume? That 2 is one of my solution, right? If I do every possible sum, including one number from this and every other number in this, if I did not find a solution, that 2 is not my solution, right? Let's see what is happening in this case. I do 2 plus 7. I immediately got 9, which is the target, right? So what if the solution had been 17? I mean, the target is 17 instead of 9. So let's do 17, because 9 it's immediately found, so there's nothing much to explore. So what I'll do is I'll do 2 plus 7, and then it's not equal to target because 2 plus 7 is 9 and it's not equal to 17. And then I'll do 2 plus 11, which is 13, which is again not equal to my target. And then I'll do 2 plus 15, which is actually equal to the target. So I found my solution, right? I found the two numbers such that they add up to the target. Now all I need to do is return the indices of them. But what if the target has not been 17 as well? What if the target has been 18, right? So what did I do? Again, I'll start from the beginning. So for the new target, we'll start fresh. Okay, all right. So again, I'm making the assumption that 2 is one of my solution. So what I'll do, I'll fix my 2, and then I'll explore every other possibility in the array apart from 2, so that I'll see if there exists a solution. Right, I'll do 2 plus 7. Well, that is not equal to target. 2 plus 11, no. 2 plus 15, no. So then what conclusion can I make from this? Well, obviously 2 is not the solution because I have explored every other possible number that could go along with 2, and still I could not reach my target, right? Simple. And then what do I need to do? I need to choose another element. Then what I'll do is I'll fix 7 as my solution. So I'll add 7 here, and then what could be my other number? So think about it. Do I need to again include 2? No, I do not. Why? Because when I first included 2 as one of my solution, I had already explored the possibility that 7 is the other solution. You do remember that? So here I have gone this way, and then I have explored this one, and I have explored this one as well, right? So if 2 plus 7 had been my solution, I would not even need to go on to make a further iterations, right? I just need to return the solution there, then and there itself. Since that did not happen, we know we don't need to like go back again and then check for the other possibilities. We just we'll check what are the forward possibilities that are possible here. So 7, I'll do 7 and 11, and then I'll do 7 and 11 is actually equal to my target. 7 plus 11 is 18, and I have reached my target. I'll return the indices of these two elements. It's fairly simple, right? So we just need to code it up, this one. But before going to the coding part, I wanted to talk about the time complexity of this. See here, the time complexity is O of n square, because in the worst case, what is happening? If the target is actually at if I select the last two numbers, then only I'm getting the target. Like for example, if the target has been 26, right? If the target has been 26, it is only possible when I sum 11 and 15, right? Otherwise it would not be possible, right? That is happening only when I reach at the end of the element. In that case, what is exactly happening is I'm making a lot of other calculations which I do not need to. I'm doing 2 plus 7, I'm doing 2 plus 11, 2 plus 15, 7 plus 11, 7 plus 15, a lot of other calculations that I might not need to. Unnecessarily, I'm doing these calculations. So I'll simply, maybe I can find a way in order to avoid these calculations in order to improve my time complexity. But in this case, the way we have, so far discussed, it's O of n square. That is the time complexity. But as asked in the follow-up question, we have to come up with a better solution that is better than O of n square. So the solution is HashMap. You might have heard of it. So what HashMap does is it stores the sum of the numbers as we move along, so that we could understand if a number is actually present in my array before. So for example, when I reach here, I wanted to know if some other number is actually present in my HashMap. So why though? Let's say I have this HashMap, right? And then this is my HashMap. Let's assume for a few minutes, and then my target is 18. Let's say my target is 18, and then again I'll start from here. So 0, 1, 2, 3. These are my indices, and now I start from here. And if suppose I say 2 is my one of the solution, well, obviously I might be right, I might not be right? So if 2 is my solution, what would be the other number? So 18 minus 2, obviously, because these two need to add up to the target, and the result is 16. And what will I do is I'll do a check. Now is 16 in my HashMap? Well, it is not there. So I'll say, you know what, maybe you are not the solution. We don't know for sure, because maybe if I go forward, maybe I'll find a 16. I don't know. But right now, as of now, I'll say, yeah, you're not the solution. But I'll store your index just in case you might be the solution. So at the index 0, you are present. Okay, I'll remember that. And then I'll move on to the next iteration. So if, again, I'll make the same assumption. I'll say 7 is one of my solution. 7 is one of the two numbers that add up to my solution. Okay, then what is the other number? 11 minus 7, because 7 plus that number is actually equal to 18. Then obviously, yeah. So 11 minus 7 is 4. Okay, I made a mistake here. One second. It's actually 18, right? The target is not 11, 18. So 18 minus 7, which is 11. And then I'll check, is 11 in my HashMap? Well, it's not there. So far, okay, maybe you are not the solution either. I'm thinking 7 is also not the solution. But before I go, what will I do? I'll add into my HashMap just in case you might be the solution. So 7 at index 1. And then I come here. And then let's say, now I'm saying 11 is one of my two numbers that add up to the target. Well, you say, now what will I do? I'll do target minus 11. and then what will I get? I'll get 7. Why am I doing 18 minus 11 here? Because I'm assuming that 11 is one of my numbers, of the two numbers that add up to the target. So the other number must be 18 minus 11, right? And now I'm checking, is 7 in my hash map? Well, I could see that 7 is already in my hash map, right? So this is why we are actually storing the elements in the hash map. Now, if suppose if I had not stored this, then I would not know, like, if there was a 7 before, if I did not encounter it or encountered maybe in the future, how will I know? Okay, this is how we will know. And the good thing about is we are actually storing the index as well, so we don't need to actually go back or loop again and find the what is the index of this element. We'll just store it in the hash map, and then we'll get the solution. Now how will I get the index of this particular element? Because I'm already on the current iteration, so I don't need to worry about it. So all I need to do is I'll just return I, and then whatever my hash map is, let's say my hash map is hm, and then what will I need to do? I'll just need to do hm at target minus my current element, right? So this is something that I need to do, that I need to return. What is the time complexity of this? The time complexity of this is O of n. Because it is a linear solution, we are not iterating over any element twice. At least maximum we are iterating over any element only once, right? So which is why it's a linear solution. And what would be the space complexity? The space complexity is O of n. Why? Because you are using a hash map in order to store the indices, right? So at max you'll be storing n minus 1 elements, but we'll actually consider only O of n, right? So the space complexity is O of n and the time complexity is O of n. So this is actually much better compared to our previous solution, right, which is O of n square. So let us quickly implement the solution. So I'll be implementing in JavaScript, but if you want me to implement in Python as well, I can do that. So please do let me know in the comment section. So first I'll have a for loop that is going from I equal to less than I less than num start length. And then remember, we have to loop from the next element of where my I is. You see, if you remember that, we were going this way and then this way in the brute force solution, and then this way. So if I fixed on my particular number 2, I don't need to again loop it from here, right? I just need to go see what are the other elements, because I fixed on one element, and I'll see what are my other elements. Num dot length minus length z plus plus. And then here I don't need to go up until the end, because I have to select only two numbers. If I go up until the end, if I go to it, there is no other element towards the right? So in that case, what is happening is I'm not selecting two numbers, I'm only selecting one number. So I don't need to go until the end. And I'll check if my numset I plus numset j, if this is equal to my target, I'll just return I comma j. That's it. So let's see if it is running. Yeah, it's working. And then let me check for a few test examples, and then it's taken too much time. Well, that makes sense because we had implemented it in O of n square. Now what we will do is we will try to implement the O of n solution. So we'll maintain a hash map. Let there be a hash map. It's actually a dictionary. You could actually use map, which is inbuilt in JavaScript as well, but I'm going to go with this one because it is fairly simple. And then for let I equal to 0, I less than nums dot length I plus plus, and then I'll check if remember what is our condition. If target minus current element, if this element is in my hash map, then what do I need to do? I need to return I, and then my hash map at target minus numset I, right? If that is not the case, what do I need to do? I need to update in my hash map that this particular numset I is actually present at this element. Let me just do this. Yeah, let's run this. Let's run. Yeah, as you can see, the runtime has definitely improved a bit, and you could also observe that the memory is not great compared to the previous one, because we obviously using a hash map which is O of n compared to the previous one which is only O of 1. So that's it. This is how we implemented it. If you have any questions or any doubts, please do let me know in the comment section. If you like the video, please do like, and I'll be uploading videos weekly now. And if you like to check out the channel and view my future videos, you're more than welcome to subscribe. And that's it. Thank you. Stay consistent.